So here we are at the outdoor condenser unit. We've talked a little bit about the indoor unit. We've energized the thermostat controls to power up the unit. What we can see out here once we pull the access cover off is that these are the contactors which will bring in 24 volts from the thermostat. And when it has the 24 volts, it pulls these contactors in and energizes the fan motor and the compressor. We can hear it humming. The contactor is pulled in. The system should be functioning. However, it's not. We're going to take our meter and we're going to check the voltage coming in. This is 120 volts. This will be 120 volts. So this is a 240 volt system. We should have 120 volts to ground, 120 volts to ground, and 240 between the two of them. Out here we've got nothing. We don't have any power coming in. We're going to go back to the electrical panel and verify that the breakers are on. And then we will come back out here and assess this a little farther. We do notice that this compressor looks newer than the rest of the equipment here. And when we take a look at the serial numbers, we can determine that yes, it is a newer compressor. It's been replaced at one time based on the condition of the outdoor unit and the condition of that compressor. Some other things we want to observe is the capacitor here is very deteriorated. That's something that might need to be repaired. And then the refrigeration lines for the low pressure side are supposed to be insulated, and there's no insulation here at all. So we're going to go to the electrical panel, check that, and then come back out here and try to figure out a little more about what's going on. Here we are at the outdoor condenser unit again. We've had some electrical problems. There's no voltage coming in out here, but we do look at the disconnect. We want to, depending on your standards of practice for the association that you belong to, you may or may not be comfortable to take these disconnects off, the covers off. If you're not comfortable around electricity, please be safe and don't do it. We can see here that we have a 60 amp breaker. We've got a number 6 wire coming in with 220 volts, but down on the load side of that breaker, we have it downgraded to like a number 10 wire, which is only good for 30 amps. So the breaker is way too large for the wire sizes that are installed here. The equipment label, which is on this side of the unit, we can barely see. The maximum overcurrent protection for this particular piece of equipment is 40 amps. So we have undersized wiring, we have oversized breakers, and that could be a problem that caused this unit to fail and the power short out, and we can't reset the breaker in the electrical panel. So there's definitely a problem somewhere between the electrical panel in the garage and the service coming out to this disconnect. So definitely need a licensed electrician to check that out.